All right, so just click that now, and hopefully we'll be getting some people joining quite quickly. There we go. So we'll give it about 3 or 4 minutes if that's okay.
Yeah,
and
absolutely.
Then
absolutely. It's not quite through yet from what I can see. So we need to include everyone. So
exactly.
won't have to repeat some things if you're at the very beginning.
Exactly. No, we're getting, yep, everyone's joining in now. I like the Zoom background you have, Princess Catherine.
Oh, I'm very proud to be part of this, and I wish there were more of them really at this point, because I think a lot of people are have a lot of concerns, they have a lot of thoughts, a lot of good ideas, and only through this kind of conferences can we express ourselves and share our experiences.
I agree, and Lifeline has done so many amazing things over the last 2 years, especially. And so I'm sure you'll be able to talk to all of us about that. So give it another 2 minutes, and then Dr. De Gascun, you can go ahead and share your slides and get started.
Great stuff. Thank you, Dimitris.
Perfect.
Who do you think the audience is going to be tonight, Dimitris?
So the audience is Trinity College Dublin's Biological Association, which is the equivalent of UCD's MedSoc, together with the International Medicine Office. So we have some faculty from St. James's Hospital. We have the members from TCD BioSoc. We have people from all over the School of Medicine because it was promoted by International Medicine Office. And we also have the Universitas 21 group from all over the world. So we actually have members from Australia, Sweden, South Africa, Chile, Mexico. We have branches in several countries. So it's them and their staff as well.
Very good.
Would both of you mind if this was recorded as well? Do you have any, if not, perfectly fine. I just.
We need it recorded because it shouldn't be forgotten.
and we can do, if Dr. De Gascun doesn't want to do that with his slides, we can always record one portion of it as well. So no issue. Dr. De Gascun, would you rather not?
Oh, no, it's fine. No, I've no objections. I'm just waiting for ladies to go first, that's all. Ladies' choice. Yeah, no, happy to have it recorded.
Gotcha. Yeah, no, it would be nice to have this as a reference for our group and to actually promote it at the Universitas 21 groups in other countries as well. So we'll send it off to, I don't know if you've heard of these universities, McMaster in Canada, London, Sweden, University of Melbourne, University of Johannesburg. So it's quite a few, and we want to promote this to all of them.
Very good.
Okay, let's go ahead and get started, if that's okay.
That's fine with us.
Perfect.
So is somebody going to pose a question or?
No, so Dr. De Gascun will start, I think, with his portion of the presentation, if that's okay. And then we'll, Princess Catherine, when he's finished, we'll bring you on board to do your portion of the presentation. Excellent. And then at the end, we'd like to have some questions. So actually, I will do my introduction, if that's okay. So hi, everyone. Welcome to tonight's event hosted by Universitas 21 Health Sciences Group UCD Student Division in collaboration with the UCD International Medicine Team and Trinity College Dublin's Biological Association. So just a quick little bit about us before I introduce our speakers. We're a subset of an organization called Universitas 21 Health Sciences, which is a group of 19 universities all over the world dedicated to international collaboration on topics of healthcare. We have members watching this event from universities in Australia, South Africa, the UK, Chile, Mexico, and Sweden, among others. And our specific branch of U21 Health Sciences has a specific emphasis on promoting the United Nations Sustainable Development Goals in relation to healthcare. Tonight's event will explore the COVID responses in 2 nations, each represented by someone critical to the response in each country. We will have each speaker talk, and at the very end, we will have a period for questions. I ask that if you do have a question, please submit it under the question and answer box at the bottom of your page so that we're able to see it and actually pose it to the panelists at the end of their conversation. We will start off with Dr. Cillian De Gascun, an Irish consultant virologist who has served as director of the National Virus Reference Laboratory here at UCD since 2013 and is the chair of NPHET, the Coronavirus Expert Advisory Group, which I'm sure most of you here in Ireland will have heard quite a lot of in the last several years. But for those of you who haven't heard of NPHET, it's the National Public Health Emergency Team in the Department of Health. And NPHET's role is to provide the best public health advice so that they can recommend to the government what they, as experts in the field, think the best actions to take are from a public health perspective. So they have been an incredibly integral part to Ireland's coronavirus response. And we're very proud to have him at UCD, and all of Ireland should be proud of all the incredibly hard work that has been put in every week to try and stay ahead of virus and save lives. So without further ado, I'd like to introduce Dr. Cillian De Gascun, and thank you very much for being here.
Thank you, Demetrius. Thank you for the invitation to speak this evening, and thank you for your kind words of introduction. Should just clarify that I'm not the chair of NPHET itself, that's the CMO, Dr. Tony Houlihan, but I was asked to chair the COVID-19 Expert Advisory Group that was a subgroup of NPHET, and then that was subsumed into HICWA's Expert Advisory Group. So a lot of groups over the last 2 years in Ireland, but hopefully I will be able to shed some light on what we've done. So I am going to, as you said, I'm going to share screen. So tonight I'm going to, as a virologist notwithstanding, I suppose, hopefully that's displaying there. I'll go into presentation mode. As a virologist, I suppose I'm going to try and stick with what I know this evening. So I'm going to talk a little bit about the NVRL itself. I'm going to talk about SARS-CoV-2, and I suppose through the course of the talk, and then I'll finish up with some of the issues that I think probably feed into the conversation that we'll have later on about how equitable or otherwise our healthcare was during COVID-19. I think there were some challenges. I think in general we didn't do too badly, but I think there are certain things we need to learn from and do better in future pandemics, because there probably will be future pandemics. So I suppose just by way of introduction, I'm going to start off with a little bit about the National Virus Reference Laboratory, because a lot of people probably wouldn't have heard much about it before the pandemic. So it was started by Professor Patrick Meenan, or should I say he started a small laboratory for virus research in 1947 at St. Vincent's. This is when St. Vincent's was in the centre of Dublin, and published The Essentials of Virus Diseases in 1951, and was quite an eminent virologist in his day. So the Department of Health then made the decision to use the live polio vaccine in the event of a serious outbreak, which is in the early 1960s. And basically the introduction of the live poliovirus vaccine led to the requirement for a virus reference laboratory for surveillance purposes. So it was agreed that this would be provided at UCD because Professor Meenan was the director of, or should I say the professor of clinical microbiology at UCD at the time. So initially set up as a temporary institution and then established on a permanent basis in 1980. So we remain the World Health Organization laboratory for Ireland for polio, influenza, measles, and rubella. I suppose just to touch, to put it in some context of what was happening at the time, and poliovirus is one of the success stories of immunization, which obviously feeds into COVID. So it was in the early 20th century that it was realized that polio was caused by a virus, and there were huge epidemics across the world through the early part of the 20th century. And I suppose what was very important in the context of poliovirus subsequently and the battle against polio was the fact that Franklin Delano Roosevelt was infected with polio in 1921. And obviously then he went on to become president of the US in the 1930s. And he established the National Foundation for Infantile Paralysis, or the March of Dimes Foundation, in the late 30s. And he appealed for victory after the Second World War. He appealed for victory against polio, and Richard Nixon made the same sort of declaration during his presidency for the war on cancer. So In 1949, then there was a breakthrough in virus culture, which meant that the virus was culturable in non-nerve tissue, whereas previously it required live monkeys for animal studies. And then in 1953, Jonas Salk vaccinated his family with an inactivated poliovirus, which was cultured in monkey kidney cells. So in 1954, there was a massive study in the US. Over 1.3 million children vaccinated with the polio vaccine trial, demonstrated to be incredibly effective. About 80 to 90% effective, and then widespread vaccination began. Unfortunately, earlier on, there was an incident where the virus contained in the vaccine was insufficiently inactivated and led to a significant outbreak of polio itself. But thankfully, that was a once-off. So in 1957, Ireland made the decision to introduce the Salk vaccine, which was inactivated. And then in 1959, trials of Albert Sabin's oral polio vaccine, which was a live virus vaccine, began. The first oral polio vaccine against type 1 poliovirus was licensed in 1960. And then, as I said, there was an agreement in principle because the live virus vaccine was capable of being shed in stool, it was capable of replicating in the wild, and it was capable of, unfortunately, recombining with wild enteroviruses and wild type poliovirus. So the National Virus Reference Laboratory was established in 1963 on that basis for surveillance purposes. And the archives from the University College Dublin can demonstrate sort of the request from the Department of Health going back to 1963. So just to go through briefly how the lab is set up, I'm not going to spend too much time on this, but obviously serology is a key part of the lab. A lot of this is automated, and typically this is indirect, where we're looking for the host response to infection. I suppose everybody's very familiar with antibodies now after all the talk about COVID. So primarily this would be sort of cold, sort of non-urgent work like antenatal screens, occupational health screens, sexual health screens, and sort of post-vaccination testing, again, as we've seen with the likes of hepatitis B and indeed with COVID. And then obviously there's some hot work in serology as well for the diagnosis of the likes of HIV, acute hepatitis, glandular fever, and other conditions. Molecular testing based around PCR. I suppose everybody's an expert on PCR now, or certainly very familiar with PCR after the last 2 years. So this is a slightly more manual process compared to serology, because the virus needs to be inactivated and samples need to be prepared. So a virus inactivation during the course of the pandemic, what we managed to do was introduce the use of lysis swabs, or swabs containing lysis buffer. So this meant that the virus was inactivated at the point of sample collection, which streamlined the process when samples got to the laboratory and allowed us to move through into sort of high throughput testing very quickly. So molecular testing before the pandemic, we would have spent a lot of time looking for other respiratory viruses, things like viral meningitis and encephalitis, and viral gastroenteritis as well. Virus isolation and cell culture. This section is again very manual, and this would be sort of traditional virology, where we're trying to grow viruses and we're looking for the virus itself and its impact on cells. This work is really too slow to be used for routine diagnostic purposes, but it's still important for our WHO reference work for characterizing viruses, typically the likes of influenza, measles, respiratory syncytial virus. We didn't, and the other benefit of virus isolation is that our growing viruses is that you can identify, you can culture viruses or grow viruses that you didn't know you were looking for in the first place. With PCR is very specific, so you need to actually know what virus and what virus you're trying to target. Whereas virus isolation, it's a little bit of a catch-all. Unfortunately, we didn't get to do much culture with SARS-CoV-2 during the course of the pandemic, because the facility was taken over for sample prep for SARS coronavirus. And then obviously we move into our contagion facility, our containment level 3 facility. And this is where we would test for things like Ebola, SARS coronavirus type 2, avian influenza. And just to put it in context there, the scale of 1 to 4. So containment level 3 facilities, or category 3 pathogens, would be serious or potentially lethal diseases through respiratory transmission. So the SARS coronavirus type 2 work began here in February 2020 in the NVRL in Dublin, when our case numbers were very small. But obviously then, just given the demand for testing, and then there was a derogation from the Health Protection Regulatory Authority, the Health Safety Agency, to allow diagnostic testing to be performed at a CL2 level. And then the final role that the NVRL plays is really around reference and surveillance. And this is a key part of what we'll be doing for COVID into the next months and years. So we're the designated WHO National Lab for influenza, polio, measles, and rubella, as I said earlier. And the key part of this is monitoring the evolution of the molecular epi of viral infections in Ireland. So the Irish government and the Department of Health will be signatories to most WHO eradication programs. Obviously, smallpox has been eradicated. There is a polio eradication program. There's a measles eradication program and rubella eradication program. So we've introduced vaccines for all of those. So monitoring and performing surveillance to look for evidence of these viruses in the wild is a key part of the work that we do. And then obviously, as with COVID, we report all sort of statutory notifiable infections to the Health Protection Surveillance Centre, and all medical practitioners and clinical directors of diagnostic laboratories are required to do that by law or by legislation. And that information then is used to investigate cases to prevent the spread of infection and to facilitate the early identification of outbreaks. It's also used to monitor the burden and changing levels of diseases. And what we've seen over the last 2 years, we've really seen, I suppose, surveillance in real time informing our practice. This is just a list of the notifiable diseases and their causative pathogens in Ireland. So many of these are viruses which we would notify, and SARS-CoV-2 is included there. So it'd be nice to be able to say, I suppose, that before the pandemic, virology over the last couple of decades had been fairly quiet, but unfortunately that wasn't the case. So obviously in the 80s, we had HIV, which was a new pathogen first reported in 1981. And then the virus was discovered in 83. And while we have great treatments, unfortunately, we never really got to a vaccine for that. Then in 2003, then obviously we had the original SARS coronavirus type 1 that emerged from Guangdong province in China. And these pictures might look like they were taken from the last 2 years, but in fact they date back to 2003 for the original pandemic. These are pictures from a civet cat on the top left and a raccoon dog, so SARS coronavirus type 1. These were identified fairly rapidly as the intermediate hosts, so the civet cat up on the top left. And unfortunately, obviously, with SARS coronavirus type 2, we still don't know what the intermediate host is. We're fairly confident what the ultimate host is, but we haven't identified if there's an intermediate host. And this information is important because it enables us or allows us to try and prevent further spillover events. So, for example, when the Chinese identified in 2003 that civet cats were the intermediate host for SARS coronavirus type 1, they carried out a massive cull at the live animal markets. Unfortunately, because the civet cat was only an intermediate host, when they reintroduced civet cats, they found out that it wasn't the virus represented and recurred. And what we learned from the first SARS coronavirus and that has informed our investigations with SARS coronavirus type 2 is that bats really are the perfect host for viruses. So there's about 5,000 species of mammals in the world, and 20% of those are bats. They're ideally suited as zoonotic reservoirs, having evolved early because they've evolved about 50 million years ago, and they've co-evolved with their viruses. So the viruses that they host don't make the bats sick, but the viruses can shed them, or the bats can shed the viruses, and then the viruses can make other mammals sick. So obviously we only walked out of Africa a few 100,000 years ago. So we've a long way to go from the point of view of immunologically evolving with our viruses and reaching a stable equilibrium for them. And this is just a picture of a famous bat cave that just shows why their behavior is sort of very suitable and lends itself to the ready transmission of viral pathogens and indeed probably other pathogens as well. That was SARS coronavirus type 1. Then in 2009, we had our first pandemic of the 21st century, which was swine origin pandemic influenza, or PDM09, H1N1 PDM09 as we call it. And that turned out to be a reassorted virus from like 4 different viruses. So influenza has a segmented genome, which lends itself to reassortment, and this is how new pandemic influenza viruses emerge, but purely because although it was a new constellation of gene segments, the fact that it wasn't a brand new virus meant that it actually didn't cause very severe disease. So thankfully 2009 was a very mild pandemic in the grand scheme of things, but it did, I suppose, give us an indication about what could happen in future years. And then in 2012 we had another coronavirus, MERS, or Middle East Respiratory Syndrome coronavirus, and that emerged in the Middle East. Now that thankfully never required the ability, as SARS coronavirus type 2 has, to spread readily from person to person. So the vast majority of cases of MERS coronavirus have direct links with animal hosts, primarily camels or dromedary camels, but the ultimate host is likely to be bats again. And I suppose what's frightening about this virus in many respects is that the mortality of this or the case fatality rate of this is up around between 35%. So if you think about a SARS coronavirus that had that level of a case fatality rate, as well as the transmissibility of SARS coronavirus type 2, it would be a complete nightmare, but thankfully it hasn't happened. And then we moved to 2014, we had the Ebola outbreak in West Africa, in countries that hadn't really seen Ebola outbreaks before. So it took them a while to bring that under control, and it really sort of rumbled on from 2014 until about 2016. And then in 2015, we had Zika, which re-emerged after sort of a hiatus of about sort of 40 or 50 years. It was originally discovered in 1947, I think, from memory. And that emerged in South America, where it caused a major problem, infected a huge number of individuals, and people remember the microcephaly that was associated with Zika virus infection and pregnancy. So virology there's been an awful lot happening over the last couple of decades, but unfortunately, or fortunately in some respects, I think nothing of the scale of what we've seen over the last 2 years. And that brings us to SARS coronavirus type 2. So this is a slide that looks at the various waves that we've had in Ireland over the last 2 years. These are based on sequence data, and these are based on the variants of concern that we've seen. So starting over on the left-hand side, I suppose this is all the lineages that we saw through the 2020 and the first half of 2021. And then you can see that alpha, appears there just before around Christmas, or sort of just before Christmas in the UK initially, and then obviously spread here. And you can see how quickly it became dominant in Ireland. That really sort of went through until the summer, and then Delta appeared, and again started off at a very low rate and then just increased dramatically because of its advantage and transmissibility advantage. And then you can see just at the end of 2021, you can see that Omicron came, and again just its rate of growth was really staggering, just almost like a vertical line. So each of these viruses getting more transmissible as they move on. But moving on to the background of SARS coronavirus type 2, people will be familiar with this, sort of the announcement in late December 2019. The new virus was announced on January 7th. And I suppose from a laboratory perspective, our role in the NBRL is obviously to try and identify and get a test prepared as soon as possible. So European colleagues published a methodology for PCR assay very quickly. So it was published in the second half of January in Eurosurveillance. So we introduced this test in Ireland on February 7th. This is a PCR that had 3 targets. We picked 2 of them, and this was the first test that we introduced. Then the problem with that test was that it wasn't really suitable for very high throughput. Because of the number of targets, it meant you could only get a small number of samples onto a typical 96 well plate, which is what you use for PCR. So then we did commercial assay introduced by early March, and then that allowed us to triple our throughput. But you can see, just to put this in context, obviously over the last number of weeks, PCR capacity has been running at a rate of about 36,000 per day. And if you look back to where we were in the early 2020, over the first 3 months of our testing through February, March, and April, over the course of those 3 months, we only did 153,000 tests. And at the moment, we're doing over 300,000 tests in a week. So there's been a huge increase thanks to the work that the HSE has done in the context of developing laboratory capacity. Pre-pandemic, we really didn't have that in Ireland. So our hospital system capacity was about 1,500 a day. And ourselves in the NBRL, we were able to build up to about 1,500 a day, but we didn't have the high throughput assays. Obviously, it was agreed then that we needed a capacity of 15,000 per day, and obviously that's continued to increase over the course of the pandemic. But really getting that up and running in the public sector very quickly wasn't really possible. So we engaged with partners in the private sector, some partners in the public sector. So the Department of Agriculture, Food and the Marine provided laboratory space out of Blackweston. Colleagues in NPHET had significant virology experience testing for bovine viral diarrhea disease, and they had experience of scale, performing at 1.4 million PCR tests a year as part of a screening program of all newborn calves for an eradication program. And then Genomics Medicine Ireland, now Genuity, had the ability to manufacture the laboratory, the WHO lab developed test at an industrial scale for us. So it was a real case of everybody sort of pulling together at the start of the pandemic to try and put a testing capacity in place. Obviously, there were many challenges at the time. People remember the supply chain issues where all countries were looking for the same thing in the context of swabs, lysis buffer extraction kits, PCR kits. logistics were obviously very challenging because we were trying to keep sick people who weren't terribly sick out of hospital and GP surgery, so they wouldn't infect others. So the National Ambulance Service went out and tested people. There were community sampling hubs, which are obviously still in place today. And then we had to figure out the challenges for sample packaging and transport because it was still a CL3 pathogen. And as I said, that led us to introduce the use of swabs that contained lysis buffer so that the virus was inactivated at the point of sampling. And then communication of results, because typically from an NVRL perspective, we communicate our results typically to the requesting clinician. So that usually goes either back to the hospital or it goes to a GP. Obviously in this situation, we needed to figure out a way, and the HSE did this, to communicate results directly to the patient. So it needed new IT links and it needed a new patient identifier. And then from a contact tracing perspective, obviously that was based on patient mobile numbers and obviously including GPs in the care pathway. And just in the context of what we're discussing tonight about equity, obviously individuals then without mobiles or GPs are automatically sort of, albeit unintentionally, excluded from that process. So this is something that we need to think about. We need new ways to link in with patients and to identify patients and to allow them to register, because even if you think about people registering for tests online, not everybody has access to online facilities. Looking at this, so the other thing from an NVRL perspective, so that was the PCR side of things. So for testing, then obviously people were curious or interested in the sequencing side of things. So these are dates that I've gone through earlier about the first assays being produced and released and announced from the WHO. And then the first iteration of the whole genome sequencing protocol was around January 22nd as well. So that was around the same time as the first PCR assay was published. So we identified our first case of SARS coronavirus type 2 on February 29th. And then by March 11th, we had generated our first Irish sequences. So our capacity for sequencing started about between 24 and 48 samples, and now we're up about 1,500 or more per week. And again, that's with the support of the Health Service Executive. So just looking at our pathway, typically we do a little bit of surveillance from the community. So we take a selection of samples from the community, but then we're also taking samples that are targeted from hospitals. So whether that's patients in intensive care, patients who pass away, or maybe vaccinated individuals where we're looking for specific measures. So those samples come to the NVRL, and then after we perform our whole genome sequencing, we feed the results then back to public health, the Health Protection Surveillance Centre, the relevant hospitals, and then we upload the data to GISAID, which is WHO curated platform, which is the global initiative for the sharing of all influenza data, and then TESI, which is the European surveillance system, typically used for influenza. And then on the right hand side here, we've got a schema or picture of the Minion, which is manufactured by Oxford Nanopore and has been used for the majority of our sequencing in Ireland, and certainly is being used in many countries as well. So a colleague of mine pulled this slide together for me last week, and just so at the moment, or as of the end of last week, we had just submitted over 48,000 samples or sequences from the NVRL over the course of the last year. And just of note, we just had just over 1,000 sequences submitted by the end of 2020. So really 2021 was where our sequencing really took off. And these are the sort of data that we generate. So again, just similar picture to what I showed earlier, just slightly more compressed. So the blue here is our older non-variants of concern, then pink is alpha or B117 as it was, red is delta or B1617.2 as it was initially known, and then Omicron in yellow on the right hand side. So I suppose coming out of the pandemic, what we will have is a hub and spoke model. So we developed this sequencing capacity very quickly over the course of the pandemic, but obviously we need to have something now that will keep us in a good place for future pandemics. So the Health Protection Surveillance Centre has been overseeing the rollout of a national surveillance and whole genome sequencing program, and we secured ECDC funding for that. So the NVRL will continue to operate as a hub, and then there are 6 regional hospitals that have been selected as spokes. So they'll be able to do local work that will inform their practice in real time, a little bit more quickly, but then anything that's needed for surveillance purposes can come to the NVRL for testing. So I suppose just a couple of slides as to where we are on SARS coronavirus type 2 at the moment in relation to Omicron. Obviously over here on the right hand side, so this is the whole pandemic from start to finish. Our initial wave in the spring of 2020, then the autumn of 2020, and then obviously that very difficult year we had, very difficult Christmas we had last year. Then you can see obviously during the summer period, levels went down to a low level again, but you can see this was the Delta wave that we see here towards the second half of 2021. And you can see how long those levels persisted at very high levels. So even though we didn't reach the same peaks as last Christmas, the sheer force of infection under the curve there is really high. And then obviously Omicron came in on top of that. So that's why the restrictions were put in place over the course of the Christmas period. And thankfully they seem to have done the job. So what we're seeing now is that our cumulative incidence, our 14-day and 17-day, are both dropping quite dramatically, which is great to see on the back of vaccination and boosting, and also a lot of infections, it has to be said. Our case numbers in hospitals are falling. I think as of tonight, they're less than 900, which is great to see. And intensive care is then, I think it's down below 90 now as well, or down below 80 actually, maybe as of this evening. So all our metrics are moving in the right direction from an Omicron perspective. And I suppose, again, just wanted to highlight this in the context of our immunization program, and again, in the context of equity and fairness over the course of the pandemic. So this slide just shows the proportion of cases notified in Ireland by age groups during the 4th and 5th wave. So that would be predominantly Delta and Omicron. And what you can see here is because, so this, I'm just highlighting this green color at the very top. I'm not going to go through the whole slide in detail, but this sort of green color at the very top relates to those members of our population who are 65 years and older. And you can see that they accounted through these waves, because they were vaccinated first and because they were prioritized, they accounted for a very small proportion of our cases over the course of the Delta wave. Now the proportion increases as other age groups are vaccinated, but they're still prioritized, and then for boosting they're prioritized as well. So you can see that they become a lower proportion as well. So our immunization program has been intended to be fair and to prioritize those most at risk and to minimize harm. And obviously this is a group that was very severely affected before we had vaccines in the first wave through the course of, especially in residential care facilities. So it was only right that when vaccines became available that they should be prioritized. So what can we do over the next, what are we doing from here on? So surveillance has become a key part of this, because realistically, we will have to stop spending so much money on testing. The amount of testing that we've done has been very important and very helpful for us. But realistically, all of that money that's been spent on testing could actually be spent on other more vital sort of health services. So at the same time, we still need to know what level of disease is in the population. So surveillance is the key for that. So this is one example. We've a Sentinel GP program where there are 60 GPs around the country that take swabs during the course of a respiratory season. So it was initially established for influenza and has operated very well over the last number of years. And then COVID-19 or SARS coronavirus type 2 was piggybacked onto that. So you can see that this pink line, this SARS coronavirus 2 positivity, actually tracks our waves quite well. So that means that we can get similar levels of information and data without actually having to detect or without having to test as many people as we've been testing recently. The second part of our surveillance program will obviously look at the virus variants. So I've touched on those already. And then on the right-hand side here, they're just in tabular form. So obviously at the moment, Omicron is the most dominant virus. It accounts for about 97, 98, 96, 97% of sequences that we're seeing. So in reality, doing more surveillance and more sequencing at this point in time isn't going to give us a huge amount of information. But what we want to see is as the prevalence of Omicron maybe drops and new things emerge, then that's when it'll become more relevant again. And then we can look at these sequences in the course of this. Is just to demonstrate, I suppose this is highlighting how surveillance is important. So these are all Irish sequences of SARS coronavirus type 2, and this is from, sorry, this maybe slightly in the way. So these are data from May 2021, and you can see B1177 was the 2020 Spanish variant, if you remember, that emerged over the summer, and then everything else is B117 or Alpha. So that was May 2021, and then by September 2021, basically Alpha has been completely whittled away. So if you think of this as a clock face, pretty much Alpha has been confined here to a little section between 9 and 9:30, and everything else has been taken over by Delta. And that's in the space of about 4 months. So surveillance from a sequencing perspective is really important. But again, we need to do the right amount of sequencing. We don't need to sequence all cases. We just need to sequence a proportion. So that will give us an indication as to what's going on. Because again, sequencing is expensive and labor intensive. And now as we move out of the pandemic, or as we start to move out of the pandemic, we need to think about non-COVID care. The other piece of surveillance that we can perform is looking at S gene target failure. People will have heard a lot about this. It's an assay that has 3 targets, but there's a deletion in some viruses that means that one of the targets doesn't work really. So this is actually a failure in the assay, but it's turned out to be very useful purely because Alpha that emerged last Christmas had a deletion that led to S gene target failure. Delta did not have that deletion, so therefore S gene was always present. And then Omicron has the deletion again, so therefore that also exhibits S gene target failure, and that has allowed us to monitor in real time the emergence of these new variants. So you can see here again, sort of the end of November, start of December, our S gene target failure proportion was really down at about 0.3%, and then by the 13th of December it was about 12.5%, and by the 20th of December it was already up to about 63%. So just goes to show how rapidly Omicron took over, and this is all exponential growth. Obviously, you'll all be familiar with the concept. Another string to our surveillance bow, if you like, is the National SARS Coronavirus Type 2 Wastewater Surveillance Program. So Vin Meyer in School of Microbiology in UCD is leading on this work. So with the assistance of Irish Water, we've got about, again, just over 60 water treatment plants from around the country that are sending samples in on a weekly basis. So in this graph here on the right, red obviously is bad because SARS-CoV-2 is detected, and green is good because SARS coronavirus type 2 RNA is not detected. But you can see really from about the summer onwards, so week 27, 28 of the year, really it's all been red. But we'll hopefully get to a stage where that will be less red in the near future. And we can also use these, just another way of presenting the data, just showing that pretty much all of the 62 wastewater treatment plants became sort of red just sort of in the second half, just at the start of the second half of the year. And really what we can do with these data as well is that we can also look for emerging or novel variants in wastewater. It's more likely we'll detect them in clinical cases first. But as I said, as we reduce the amount of routine testing that we're doing, because we don't need to necessarily test everybody who's previously well, has no underlying conditions, and isn't at risk of coming into hospital or doesn't need hospital admission, then wastewater surveillance may become more relevant. And the reason we're doing all of that surveillance is really to look for variants of concern. And this is Omicron. So these are data from NextStrain. This is just sequences comparing the different variants of concern that we've seen over the last 2 years. And you can see you don't need any background in medicine or virology or science really to see that Omicron is obviously very, very different. It's got a huge amount of additional mutations, or many more mutations than other variants that we've seen. But what's interesting for us is that Omicron actually emerged in the middle of 2020. So this long red line dates back, as you can see here, to the middle of 2020. So it's not a new variant. It's been circulating somewhere for a while. So we don't know where it's been. Has it been circulating in immunocompromised individuals, evolving, acquiring new mutations? Has it been in an animal reservoir host, or has it been somewhere else? So at this stage, we ultimately still don't really know. And we want to know that because it might help us predict or anticipate or detect other variants more quickly. And you can see Omicron, this is just the growth rate. You can see Omicron in green here. Like we thought Delta was bad, and Delta was bad here in the lavender, but Omicron just knocks it out of the park from the point of view of the growth rate. And then all of the additional mutations that Omicron has will have an impact. So when we see mutations or we see variants like this, our concern obviously is what impact it will have on vaccination. And we've seen, people will be very familiar with the neutralizing antibody terms now. So we know that Omicron is more difficult to neutralize with antibodies than Delta and than Alpha, but thankfully the cell-mediated arm, or the cellular arm of the immune system, has still been maintained. So what we have seen with vaccines, so this is just one example slide. So you can see in the black squares here, we have Delta, and then in the gray circles here we have Omicron, and this is a vaccine effectiveness percentage here on the y-axis on the left hand side. So you can see the massive difference after 2 doses of this is a Pfizer-BioNTech vaccine, and then you can see then if we add in a booster that you do get a boosting response. Now there's still a difference between Delta and Omicron, but you get an impressive response to boosting. So that's why it was so important for us to get as many people boosted as possible. And the other good news in the context of Omicron and vaccination is that the vaccine effectiveness here on the right-hand side against hospitalization after your third dose stays really, really high, which is really good. And then some positive news, I suppose, to finish on Omicron. And one of the reasons that it's probably so transmissible and perhaps causing milder, less severe disease is because it's replicating in a slightly different area. So we have three, this is comparing Delta with Omicron. So HAE is human airway epithelial cells. And you can see that after 24 hours, Omicron completely outcompetes Delta in the upper airway. In other sort of standard ACE2 temperate cells, they're fairly equivalent, although Omicron is probably slightly higher there. But then in CALU3 cells here on the right-hand side, this is a cell line derived from lung tissue, and you can see that actually Delta replicates better than lungs. So this would suggest, or this would sort of support the context that Omicron doesn't get into lung tissue as well, and therefore is probably less likely to cause severe disease. However, it replicates very well in the upper respiratory tract and nasal airway, in the nasal tissue, and therefore it's replicating there at a high level, so it's very readily transmissible. And that would lead to this sort of feeding onto the risk assessment why infection severity is probably less with Omicron than others, purely because of its site of replication. So to sort of finish off on the summary slide and just to take us back to the conversation, I think I would sort of suggest, based on my experience over the last couple of years, the nationalisation program in hospital care have been very equitable through the course of the pandemic. I think it's probably in preventive care that we've fallen down, because people remember we've had struggles in residential care facilities because healthcare workers had to work in more than one facility, and they couldn't stay out because if they stayed away from work, they didn't get paid. So we need to look at the living wage. People remember the outbreaks we had in meat processing plants, and again, that feeds into the ability to stay home when they're symptomatic. They had no statutory sick leave, no statutory sick pay, and again, if they don't go to work, they don't get paid, and people can't afford to take that chance. And we also learned, certainly I learned from the point of view of meat processing plants, that a lot of these workers were living in shared accommodation and shift work, so they were even sharing beds where one shift would go in the morning, the night shift would come home and hop into the same beds. They were sharing transport. So trying to control outbreaks in that setting was really difficult. And then obviously we saw the same type of thing in direct provision centres where people's ability to self-isolate was very challenging. They didn't have support for people to go to the shops for food, for essentials. So again, controlling outbreaks in those settings was very challenging. And then for vulnerable populations in general, like we had challenges identifying specific groups for our immunization program, people who had conditions that made them immunocompromised, people who were receiving biologics. So we really need a unique patient identifier for that to come out of this, so that we can track people and identify who they are, who's most at need, and what they need. Because as a society, I think it's important that we learn from this pandemic, so we're better prepared for the next one. And there'll certainly be a next one. Hopefully not in my lifetime, but there certainly will be a next one. And I will finish up there and stop sharing. And happy to take questions later on. So thank you very much.
Perfect. Thank you very much, Dr. Gascun. Very interesting to hear from someone who's at the top of their field. And it's not very often we get to do that, especially with all the misinformation that's out there. We have so many different sources of information nowadays, and it's nice to actually get something from the expert himself. So thank you very much. We already have several questions that have come in. We will ask those at the end, if that's okay. Perfect. And I would like to introduce our next speaker, Her Royal Highness Crown Princess Katherine of Serbia, who among many, many wonderful things is the patron of a foundation called Lifeline, which according to its mission statement provides aid for medical institutions in the form of medicine, medical equipment, medical training, and reconstruction projects. And in addition, the foundation addresses needs of children with medical and physical disabilities, children with special needs, and orphans. Princess Katherine and her foundation have been instrumental to the COVID-19 coordination and relief effort in Serbia, bringing awareness and funding to areas that would have otherwise been neglected. Lifeline also has offices in the United States, Canada, the United Kingdom, and Greece. And Princess Katherine has really been a true humanitarian for a very long time. And it's a true honor to have her here today. So I would like to start off by sharing my screen because Princess Catherine asked me to share a video with you all. If that's okay, Princess Catherine?
Yes, of course.
Perfect. Okay, so I'm just going to play a couple minutes of this video because I feel as if it really introduces your work very, very well. So I'm just going to do that now. Okay. Sorry, it's just opening some system preferences here. Okay. So let's try this one more time. Here we go. So just going to share the screen. Can everybody see that? Perfect.
Supporting the others, helping those that are in need, love towards everyone, always being there for the people of Serbia, to listen to their problems, understand and help. These are the ideals that lead Her Royal Highness Crown Princess Catherine in her devoted work to provide aid to all the people who need it, regardless of their gender, religion, race, age or ethnicity. Making a difference. Jubilee of Her Royal Highness Crown Princess Catherine Foundation in Serbia. From the time she was born, her parents taught Her Royal Highness Crown Princess Catherine the joy of giving. This childhood learning experience has set her on her lifetime journey to help others. She brought cows to India with Princess Irene of Greece for children to have fresh milk. She also brought fresh water to Burma by starting projects to drill wells with clean water. These are just some of many humanitarian acts. But nothing inspired her more than when she met and married Crown Prince Alexander. Seeing the great love which His Royal Highness has for his nation inspired her to focus all her humanitarian activities on the people he admires and respects, the same nation she fell in love with quickly. Crown Prince Alexander also learned from a young age to always help his people, continuing the work of his parents, grandparents and all his ancestors. Unfortunately, their highnesses could not be with their people in the country and help them directly. Crown Prince Alexander was living abroad in an unwanted exile. He was born in Claridge's Hotel in Suite 212 in London on 17 July 1945, which was temporarily declared by the British government to be Yugoslav territory for the birth of the future king. The godparents of Crown Prince Alexander on his baptism were then Princess Elizabeth, now Her Majesty Queen Elizabeth II, and her father, His Majesty King George VI. Crown Prince was living abroad due to the decision of the non-democratic regime that ruled Yugoslavia after World War II, which deprived the royal family of their citizenship. This included His Royal Highness Crown Prince Alexander, who was not even 2 years old at the time. By doing this, the communists tried to deprive the members of the Karađorđević family of that special bond that every person in the world has with the homeland and with their countrymen. They tried, but they could never succeed. Although not in the country, they worked together to alleviate the suffering of the Serbian people and bring some hope for a better future. Throughout the war, and by being the only private few with a license to bring aid to the former Yugoslavia, their highnesses provided convoys and convoys of aid to those in need, distributing them throughout the war-inflicted country. It was difficult for both of them to hear the stories of the tragedies and also not to be able to be with their people. As Crown Prince pushed for bringing democracy and lobbied against the bombing, Crown Princess was determined to make the lives of the people better in the way she knew how, through large amounts of humanitarian aid, which came directly to the people and thousands of orphans that were inflicted by the terrible war. It should also be mentioned that one of their first projects together was the donation of isolation, a sterile room for hematology patients to University Children's Clinic Tiršova 30 years ago. This carries a lot of symbolism in it, because the hospital in Tiršova was built by Her Majesty Queen Maria, the grandmother of Crown Prince Alexander. The needs were great, and Crown Princess Catherine needed a lifeline, so Her Royal Highness opened offices of Lifeline humanitarian organization in Chicago, New York, Toronto, London and Athens that all work under her patronage. Hard work and efforts of all those wonderful people who have been supporting and helping the work of Lifeline offices for over 25 years now have made a tremendous positive impact for the people of Serbia and the Republic of Srpska and made a difference in their lives. Their Highnesses were always dreaming of the day when they can be home with their people, deliver the aid themselves and hear their needs firsthand. When asked by the children, where is her crown? Crown Princess Catherine always answers, my crown is in my heart. Without love, we have nothing, and love towards her people and her country is what keeps Her Royal Highness going. I want to be able to touch as many lives as I can. We will always work for the benefit of all those in need, regardless of ethnicity or religion, since we believe that there are no borders in suffering. Crown Prince Alexander organized conferences with the opposition to unite them against the non-democratic regime which ruled Yugoslavia at the time. His contribution and great efforts brought democracy to Serbia, and their Highnesses were invited by the government to live in Serbia in July 2001. Almost every day, Crown Prince Alexander and Crown Princess Catherine traveled around Serbia to different cities, meeting the people, hearing their needs, delivering aid, and giving them the support and love they deserved. Within months of their return in July 2001, Crown Princess opened her office in Serbia, which she dreamed of establishing for so long. With her Lifeline offices abroad and the Serbian Crown Princess Catherine Foundation, they were able to make an even greater contribution to the well-being of people in Serbia and the Republic of Srpska. She continued strengthening the network of Making a Difference for Serbia, united with doctors, government and other humanitarians in Serbia, putting the efforts of all of them together for a greater good.
Osnovni pokretač fondacije princeze Katarine.
That was a wonderful introduction to the work that Princess Catherine and Prince Alexander have done in Serbia and all around the world. And we would love to hear some more from you, Princess Catherine. So please go right ahead.
First of all, I would like to thank you, Dimitri, very much. Dimitri Smith has brought me to this wonderful opportunity to talk about the work and how we can help during COVID times. Of course, doing what we did before COVID times has helped, because we knew what we had before and we know what we have now, and we know how to help, how to go forward. And we are hoping that that will make us more contagious not in the COVID, but contagious in people realizing this is the moment to give of ourselves. When we arrived in Serbia 20 years ago, I was asked to be the official coordinator for the health of the country by the Minister of Health. And of course, when COVID came, everybody sort of looked at me and say, you can help us. We know you can, please do. So there's so many different ways that the requests have come through, which is ways that I wasn't really ready for it or expected. But for example, we had some laws in Serbia when we had COVID that nobody can be on the highway driving and going around unless they have permission. But the doctors couldn't get their permission fast enough, and that were needed in the hospital. So I got a call from our main hospital saying, we need 30 rooms starting tomorrow night. We have to keep the doctors here. So I had to find a hotel across from the hospital to be able to keep those doctors there. So the next thing I knew was how do we keep the people from going around, passing it around? How do we make aware of everybody? And so I had to deal with all that. I got a call, for example, from the hospitals, we need computers. Why would you need computers right now? It says we need computers because there's so many patients. They come in, we write in the paper, you know, what's wrong with them and tell them to come back in 2 days' time. And when they come back, they lost the paper. So we cannot just give them something and trust that they will bring it back. We have to have computers in order to be able to put every patient in the computer, and when they come back, we know their status. We don't have to re-examine them again. So there were issues like this that really surprises me when this happened, because there was a lot of concerns, but there were also many people who have helped me. For example, Mayo Clinic called me up. They had somebody from Bosnia who spoke our language as well, and he said he's ready to help. So I organized conferences between the head of COVID in our country together with Mayo Clinic that were able to discuss what they could do and being able to go forward. So there was even meals in the hospitals. Who's going to cook for the patients? Who's going to cook for the doctors, the nurses? There was so much shortage. I mean, so many problems, so much was happening. So we organized meals to go around to the hospitals in order to eliminate their concern in that area as well. So, you know, there was also a big need for delivery rooms, for example, because the young couples can't go anywhere at night. They stay home, and then we end up with many babies. So as it turned out, we had to find a way to do delivery rooms. We didn't have enough. I'm in a process right now of completing a delivery room in a children's hospital, and it's going to be fully equipped with the equipment we need. So there is so much that's coming forward that we didn't have before. For example, we have 1,000 orphans that every year they come for Christmas and Easter to the palace. Because we cannot keep them together now because of COVID, we have to deliver 1,000 gifts to these 1,000 orphans. We have, for my husband, for example, awards 600 students from 600 high schools every year to come to the palace to award them for being the best student. We couldn't do that. We had to deliver their awards and their bag and everything to them. Everything has changed in the way we go forward, in the way we try to help the people, and in the way we try to make a difference. For example, we are desperate for beds, desperate for beds. So thanks to Colorado, to a very dear friend, Douglas Jackson, who is the CEO of Project Cure, he's been sending containers. I just received one last week with all these reclining beds, and as well as hundreds of thermometers and all that. There is a situation where you have to continue helping, because there's no time to sit back. There's no time to observe. It's time to make a difference. And that's all there is. There is no argument. There is no question. There is no confusion what we make a difference in. We need to help our doctors and our nurses who are risking their lives to save the lives of others. So we need to be there for them, and we need to help them. We need to also think of how we need to keep things clean, like the children, for example, in the schools. We have taken all the schools in Serbia, and we make sure there's toilet paper, make sure there's paper towel, make sure there's disinfectant soap and all that, because we need to teach them to keep clean their hands, to wash them, to do all that. So every time I turn around, there is a new project that we have to take over, because the country is overwhelmed with all the responsibilities, and we are the ones that have to pick up the pieces. Thanks to the offices I've had abroad for the last 25 years, in Chicago, in New York, in Toronto, Canada, in London, and in Athens, we've been able to help as much as we can. But you know, it's not just Serbia. For example, in Greece, last month, we had a big event for incubators, because the parents and the atmosphere, they're all so anxious. A lot of the babies are born premature, but we don't have enough incubators. And if we send them somewhere, we're taking a risk of a newborn baby being born early to send them to another hospital. So we managed to do a whole unit at the Elena Hospital, and we are now filled it up with incubators. So when babies come early, they can be saved, and they don't have to be traveling anywhere else to find an incubator to save the baby. There is so much to do at this time. And what I would love to see is for everybody to play a part to this. It's so important. You know, I remember when I got the call from the doctors at Mayo Clinic, and they were ready to help us. I didn't want to hang up and give the phone number of who they call. I said, just a second, I have another mobile. So in my other mobile, I called the doctor. So I had Mayo Clinic on one side. I have the head of COVID in Serbia, and I connected the two mobile units and said, speak. I don't want to take my chance of you calling each other. We must make sure that we help and we're effective in what we're doing. And there's so much one can do. A lot of people don't quite understand the needs that exist. A lot of people don't know that they can make a difference, but they can, and they have to believe it. And I'm trying to tell everyone can make a difference. It doesn't matter of the religion. It doesn't matter where they are, what they're doing, what they know, what they don't know. This is the time where we have to unite all of us together, regardless of religion or ethnic origin, and make a difference. This is the only way we can save the people who have become victims of this COVID, and being able to go forward and have respect for one another and try to see what we can do. We have to encourage people to be vaccinated. There is no way out of it. And, I feel it's so very important for people to understand the importance. It's not, they're not just get vaccinated only for themselves. If it's for the whole world, we are all together in this. There is no difference what country you come in, whether you're a man or a woman or whatever you are. This is something that we have to save each other, and we have to care for one another, regardless if we know their names or if we speak the same language or whatever. We are human beings. God has brought us on this earth, and we need to try to save one another. And I believe that this webinar like today, with all this wonderful explanation we have, how we started, where we are, how we can combat this has been so very helpful. And congratulate Dimitri for putting it together so beautifully. But we need a lot more than that. So I hope that this is the beginning of many more ahead, because we can't do this alone. We need support from everyone, and we can support each other. There's no question about it. I'm happy to answer any questions that anybody might have, but at this point, I think that we do need to take it much more serious than what we have. It has taken far too long for people to realize what this is all about. What do we have to avoid? What do we have to do? Far too long. And I believe that it's very, very important that we now share with what we know with others and try to get people to understand that we have to hold hands and go forward together and try to keep up with what's happening, respect the countries, respect the laws, and follow the instructions that we have. We don't know a lot, but we need to respect and follow those who do know and who are spending their lives getting to understand this better and better each day. And we can't lose time by saying, I didn't know this. We don't have the right to say, I don't know, because nowadays the information is everywhere. And it's a matter of not waiting until one gets COVID to get interested, or to lose a member of their family to get interested. Let's all hold hands and go forward. We can combat this if we understand it, if we respect it, and if we stay together and do what we can. We have to help each other. We have to be like brothers and sisters, and no titles make a difference. No, nothing makes a difference. What we need to do is to care for one another and to save. Each life is important and precious, and we must save it. And so thank you again for this opportunity to bring me to this webinar and to be able to share my experiences in my country and in Greece and in other countries, that we can do it. It can be done. And if anybody has any questions, how or where or when, I'm happy to talk to them and help them in any way I can. Thank you, Dimitri. God bless you, and all the best to you.
Thank you very much, Princess Catherine. It's incredibly important to remember that, yes, this is a pandemic, and but we're all human, and this affects every single one of us in the same way. So it's important to see the human aspect from it, and to see how it actually affects people, and how it affects the most underserved people, and how you've actually come together to help those underserved people. So wonderful. Thank you very, very much for all that you do in several countries all around the world. And to get things started, we have a question for you. How much did the demand for supplies go up during COVID? And do you think that your experience in obtaining those supplies during COVID will help you in the future to get more supplies? How have you, how did Lifeline and how did you manage to obtain the beds and the computers and everything that you mentioned during COVID? And you think that that will help you in the future in order to get these supplies?
Right. It is not as easy as it used to be because we can't have the gatherings we used to have. But we stay on top of it. We talk to the people. They see the difference we're making with every one of their donations, and they want to do more. They want to do more because they feel helpless without some support. So the Lifeline officers have created a support for them, a pipeline, where now they know how to help. Because there is people who want to help, but they don't know how. And this really breaks my heart. I believe that there is big hearts among people. I believe that people do want to make a difference. And by having those lifelines and keeping to our database information from the people, how they can help, what we need, what is happening, we must be exchanging information as much as we can. And we must believe that there is a way forward. And we need to apply ourselves now. There's no time to wait. Sometimes people think, well, I'll do it next month. There is no next month, there's today. And that's what we have to realize and to do. And I'm very proud of all the lifelines who have been working so hard in making this possible. So, and I thank you for giving me the opportunity to share this with the people who are listening. If there's anybody who would like some more explanation, or they would like to know more about how they can help, I'm happy to talk to them. Not only our foundations, with other foundations, with other countries, with other people. I'm there to help. For me, this world is small and doesn't scare me. I'm ready for anybody at any place at any time. Thank you.
Absolutely, and we have an audience from all over the world, so it definitely is very pertinent. So a question for you that's come in, Dr. De Gascun, will the huge amount of COVID testing affect the speed of getting other laboratory tests done for other diseases, and has it affected testing for other diseases?
So no, it's not affecting testing for other diseases at the moment, but certainly through the first year of the pandemic, it would have had an impact because a lot of the testing was being done in our own lab and also in the hospitals, but without the necessary infrastructure, if you like. So through the course of the first year, the HSE procured a huge amount of equipment, and with the assistance of Professor Mary Keoghan, who's the National Clinical Lead for Pathology, the hospitals got additional sort of high throughput platforms. So that capacity in the hospitals went up to about 6,000 a day from about 1,500. And then additionally, from our perspective, there's a new laboratory came on stream at Back Weston, again with the support of DAFM and the HSE, and that had a capacity of between 4,000 and 6,000 a day. So basically it meant that once our COVID testing moved off site, it allowed us to go back to performing the routine work. So yeah, there's certainly an impact in the first year, but most things I think probably have settled back to normal from a laboratory perspective now.
Understood. And I'm assuming as we ramped up the testing capacity, it was easier for you to get back to doing what you would normally do.
Exactly. And so the other impact as well was that people weren't presenting for other conditions either. So the lab stuff did certainly switch off, but also the demand for non-COVID work kind of fell off a cliff as well. So things weren't as badly affected as they might have otherwise been.
Understood. And a follow-up question from Doyle. How do they manage care of homeless people with COVID and controlling those outbreaks, dealing with contacts, that sort of thing? What would you have any idea how they managed care of homeless people during COVID?
So unfortunately, I didn't have any first-hand experience of it. I know there's a couple of inclusion medicine consultants, one in Trinity and James and Tarmaginty and Matter. So there were sort of outreach programs, and there are the likes of Safety Net who work with homeless people as well. So I think insofar as was possible, they managed them on their terms and worked with them and tried to provide what they wanted. So if they were looking for temporary accommodation, I think that was provided to them. If they chose not to, I think they were meeting them sort of out and about. But
right,
I think I suppose we didn't really there was little enough that they could do from an antiviral perspective. So most of them, obviously, if they needed medical care, then they would have been referred to the nearest hospital and brought in and managed there. But I suppose the majority of them probably wouldn't have needed care. So and I guess the majority of them wouldn't, if they were on the streets, they wouldn't necessarily have had a huge number of close contacts. So, but it is very challenging, and obviously we know that a lot of people living on the streets don't necessarily want to go into the hostels that are available. So again, it's a societal challenge I think that we really need to try and address, so that everybody who wants a bed should have access to one. Understood.
And there's word in the media, also from Ellen Doyle, there's a word in the media that we're entering the endemic stage of the pandemic or of the virus. Do you have any idea from previous pandemics that went through this phase, how long it takes on average during the life cycle of the virus? For example, the Spanish flu becoming a common cold strain. How long does it take for a virus such as COVID to reach the point where it becomes as harmless as the common cold?
We don't know, is the short answer. So prior to COVID, so we have 4 seasonal human coronaviruses, and they have all crossed the species barrier at some point in the past. The problem is nobody who's alive today was alive when that happened. So we don't know how long it took for it to settle into an endemic disease. Like the challenge with I suppose the pathway to endemicity is that typically when the virus crosses the species barrier, if it gets established, the most susceptible, the most vulnerable to that infection will die. So when we say that viruses tend to evolve towards being milder, that's because they kill the people that are susceptible at the start. So we obviously couldn't sit back and let that happen. So we intervened with, intensive care, hospitals, dexamethasone, vaccines. So paradoxically, by intervening, we may sort of prolong that journey to endemicity, but obviously we have to do that. Ultimately, an endemic virus reaches an equilibrium with its host based on immunity. So in the pre-immunization era, or pre-vaccine days, that immunity was built up through repeated natural exposure. But obviously, again, we couldn't let that happen because, in the first wave, we saw the damage it wreaked on the elderly and people with underlying conditions. So we've introduced vaccination, and the question is how long that will survive. So what we ideally want to get is probably a combination of vaccine-based immunity, and then people will get exposed to Omicron or whether it's the next variant, and then that will boost their underlying immunity. So over a period of years, we'll get a global population that has been exposed to the virus either through vaccination or through natural infection. But the problem is we don't know how long it takes. Like, again, there's always a temptation to look at Ireland, but like we've got to think globally. Huge swathes of the population haven't been vaccinated yet. So this is, if you start from 2019, this is a 5 to 10 year process, I would think.
Understood. Okay. Sorry, go ahead.
Whenever it's appropriate, let me know. I'll have a question.
Of course, please. By all means, go ahead.
I would like to say something that is bothering me very, very much, and that is the following. We are trying to prevent for people getting COVID one from another. But if somebody is not feeling well, and if they're suspecting they got COVID, but they don't have a way to find out, then they're exposing themselves every day to many people who end up getting COVID from them. And what I would like to see, if possible, to come up with some testing that they can do at home that is not as expensive as it is right now. And it's so, and it won't be as difficult to find these packages even to do them at home, because we can eliminate a lot of COVID by people being careful once they have COVID from passing it on to others. But we are not giving them the opportunity. And since a lot of times this COVID makes you feel like you have a cold or this or that, you know, sore throat or a cough or something like that, people cannot identify whether this is COVID or it's not COVID. But we have not found a way to tell them, look, if you are suspecting that you might have it, we can't just say, just stay away from people, because it's they might do it or they might not do it. But if they can see that they do have COVID, then they will take the necessary steps. So I just wish there was a way for people to find out if they're suspecting that they have COVID, not to have to make an appointment or to find a pharmacy or to do this or that. One goes to 3-4 pharmacies and nobody has available those packages that you can take home and test for yourself. So that is a big weakness that I think that it's a shame that we haven't been able to find a way forward. And I would like to see that one day.
Absolutely, Princess Catherine. Actually, that brings me on to a very good question for yourself. With the people that you're serving and the people that you're giving supplies to, have you been able to procure COVID tests in Serbia and Greece for them? Has it been easy enough to procure COVID tests for the people that you're giving supplies to? Have you tried? Is that something that you and Lifeline have done?
Yes. You mean Lifeline event, did you say?
Yeah, yes. So does Lifeline have ways of procuring COVID tests for?
Well, we had an event in Greece this December, and we had 300 people. And we don't want to encourage people getting together in big groups. So the only way we could do it is either not having anything, not to do it at all, or to try to find a way forward. So what we did is everybody had to send us in advance the vaccination certificate to start with. And everyone that was going to come to that charity event had to have a test within 24 hours from the time of the event. Otherwise, they were not allowed in. So it took a lot of work with 300 people to be able to achieve that. But the people were all hungry to come to help and to get out as well, because they've been locked in for so long. So we did extremely well. We got all these incubators for the hospital I mentioned earlier, thanks to this event. But we had to have very strong demands from the people attending before they come. Vaccination is one, and secondly, within 24 hours that they have check themselves and they have a certificate that are free from COVID. So that's the only way one can do any gathering of any kind. I wouldn't feel safe. There's not enough, there's not an amount of money that could be worth having someone get COVID and you know, even die. You know, it's not worth it to do any delivery rooms or any incubators or anything else. We have to find a method to do and to do it properly.
Understood. And it's very important. Yeah, you're right. Whenever you have an event of that nature, you have to have people being tested. And Amanda from University of Melbourne made a very good comment just now that in Australia, they have rapid antigen test kits that are home tests and give results in about 15 to 30 minutes. But the main problem there as well is limited availability. and are usually reserved only for people who have confirmed exposures to positive cases and have started developing symptoms. So it's definitely something, especially with the rise of Omicron and how contagious it is something that we have to think about in the future of how do we make testing easier, especially if COVID is going to be with us for extended periods of time. One final question for Dr. De Gascun, if that's okay. How can we avoid the next pandemic? What can we do? I mean, it's a very open-ended question, and I'm aware, but what is the work that you're doing and the National Virus Reference Laboratory, or what can we do?
Stay away from wild animals. If we look at where our previous pandemic viruses have originated, you know, like there are hundreds of coronaviruses, for example, in bats, and bats obviously are mammals. We're mammals, so every virus that is every cellular receptor that a bat has, chances are that humans have an analog of that. So if the virus can infect a bat, it's likely that it can infect us as well. On the flip side, on the other side of that, then if we look at influenza, there's probably tens of different types of wild of influenza viruses, avian influenza viruses in a wild avian reservoir. So ultimately, in the globalized world that we live in, and I suppose the way that that humankind is continuing to encroach on the wilderness, it's really next to impossible for us to prevent future pandemics, I would think. But from a preparedness perspective, I think we need to be looking at things such as, you know, universal vaccination. So rather than sort of vaccinating against a single influenza virus and having to change it every time the virus changes, you try and identify an area of the virus that is conserved across all the different types and include that in your vaccine. And you try and do a similar thing with coronaviruses. But the problem is, it's like with pandemics, it's like the old adage about generals fighting the last war. You know what I mean? Like, we thought when COVID came that it would, and sorry, you know, I think we still have to learn from past experiences, but you know, we thought it might be like 2009. But the thing is, this is really the first time in our lifetime that a brand new respiratory virus has crossed the species barrier and gone global. You know what I mean? We had a dry run in 2003, but that was really, it was luck that got us out of that, because the virus wasn't really very efficient at transmitting from person to person. With MERS in 2012, that was luck as well. The virus didn't become very efficient. With H5N1, avian influenza, the virus doesn't transmit very readily. It's got a mortality rate of 50%. But so ultimately, like, these things by chance will happen. Like, you know, I suppose it's like the old, I hesitate to use the analogy, but it's a bit like the terrorism analogy. You know, we've got to be lucky lots of times to get away with this. Like, the virus only needs to get lucky once, and SARS-CoV-2 just like got really lucky. And from a virology perspective, it's fascinating to be able to watch this unfold in real time. I don't want to go through it again, but I think we have to try and learn as much as we can from what we're doing. And I think it comes back to the point that Princess was making, that we're resource poor in many respects. You know what I mean? We can't provide all of the tools that we need to all of the people in the world at the same time. Like, you know, all of the rich countries have hoarded, you know, testing equipment, they've hoarded swabs, they've hoarded, you know, antivirals, they've hoarded drugs, they've hoarded rapid antigen tests. And the problem is that money talks. And even from a vaccine perspective, with the manufacturing and the contracts and the intellectual property and the patents, you know, like even things like waiving patent legislation to allow the likes of India to manufacture vaccines, like all of those things, like we're not thinking as a global community, which I think is a real concern. And that's the biggest lesson from all of this, that if we don't think globally, then, you know, none of us is safe till all of us is safe in many respects.
Right. No, understood. And it's a very sobering thought. And we really need to work together, I think, as the human race, to really think about the risk that a future pandemic causes to all of us, and to really try our best to listen to experts such as yourself, and to support the work of humanitarians such as Princess Catherine. So I thank you very much for being here today. It's wonderful to hear from, again, both from a leader in the field, from the scientific field, and a leader in the humanitarian field, from two separate corners of Europe. So it's been wonderful hearing from both of you. We have our Associate Dean, Dr. Patrick Felle, with us, who is also the Honorary Consul to Oman from Ireland. Princess Catherine is also familiar with the royal family of Oman as well. But he would like to give some concluding comments, if that's okay with both of you.
Of course.
Thank you very much, Dimitri. Your Royal Highness, Dr. De Gascun, and friends and colleagues from all around. It gives me great pleasure to join you in this wonderful webinar this evening, and my apologies for being late. I was at a meeting and couldn't get out. COVID has been a difficult time, I think, for all of us. It's been a very difficult 2 years, and fingers crossed we're coming to a certain phase of it at this stage that we'll be able to handle a little bit better. I think I'm sorry, I'm in the car here and something's just decided to switch off. Oh, I'm not sure why that's happening, apologies. Oh, there we go. Yeah. It's been a difficult time. Many of us have lost friends, relatives. Many have suffered sickness and ill health and are continuing to suffer with long COVID and so on. But in many ways, something that's happened with COVID, there's been a spirit of certain amount of cooperation. I don't think we'd seen before, even if we look within Ireland, the massive scale of cooperation that led to the early stages of taking care of people who were very, very ill, and then the early vaccination programs. I know when people like Dr. De Gascun and myself and so on, as healthcare workers, got vaccinated in the early stage in what were set up as temporary military hospitals for some of us, and so on. And that's sort of cooperation we had not seen for quite some time. And there was a great spirit. There was very, very tough times. And hopefully we've learned from that, and from that cooperation. We learned, I think, how interdependent we are on one another. Even those of us from the wealthier part of the country of Ireland, we were very dependent on people from very poor backgrounds living within us, people in the meat plants we referred to earlier, who did some really, really hard work. The healthcare workers, the healthcare assistants particularly, many immigrants living in very, very difficult circumstances who worked really hard caring for the elderly who were dying, and very, very difficult times. And I hope we've learned how dependent we are and how much we owe people, how much we owe other people. I think something else that we do need to learn, and I don't think we've learned, Dr. De Gascun referred to it, is our dependence on the rest of the world. The latest Omicron came from because of poverty in South Africa and lack of vaccination in South Africa. And I think, as Dr. De Gascun said, it's not over until everybody's cleared. And that's something we've got to learn, and we've got to share our wealth with the rest of the world. And I do hope that will happen, or some of it will happen. I won't keep you. It's been a long evening, and I want to thank Dimitri especially for a really fantastic job on putting this together and bringing such a distinguished audience, Her Royal Highness for joining us, and Dr. De Gascun for your time, which I know is very precious. So thank you very much, everybody, and I'll hand back to Dimitri to close.
Thank you very much, Dr. Felle, for your kind words. I'd like to also thank the other members of Universitas 21 Health Sciences Group UCD Division, who have worked really hard to make sure that this was a great event, and the International Medicine Office as well at UCD, and particularly Smaranda, who has really helped us. And the Trinity College Dublin Biological Society Association, because again, in spirit of cooperation, we decided to have several universities in on this. So thank you very much, Princess Catherine. Was a pleasure hearing about all of the work that you do, and please continue doing such a wonderful job. I've been following your work for years, and it really, there's no one who really touches lives quite like you.
Very good. Congratulations for you as well for putting this together. We need more people like you, Dimitri. And I hope you're contagious in that area, in other people wanting to follow your way of doing things. And I enjoy so much listening today and learn a lot. And thank you very much. This is a topic that cannot supersede any other topic. This is our life now, and this is part of, we live with this, whether it's day and night, or whether we're here, or whether we travel, or whether we work. It is part of our life, and a big part of our life, and we have to hold hands and go forward and share our experiences. Thank you for giving me the opportunity to share my experiences with COVID. Thank you very much, Dimitri.
I hope a lot of other people have the ability to hear that experience as well. And Dr. De Gascun, thank you so much for all the work that you do. You've become quite a famous figure in Ireland during the pandemic, and for very good reason. So we're truly honored to have you here today, and to hear from the original source of information on COVID-19. So thank you so much. And Dr. Felle as well, thank you. Everyone have a wonderful night.
Thanks, Dimitri. Thanks for the invitation.
Thank you.
All the best.
Bye. Thanks, Catherine. Thanks, Dr. Felle. Bye.
Thank you very much. Your Royal Highness, I've just returned from Oman there last week.